Okay, so let's start. Okay, so today we are going to discuss transfer learning. So up to how much did we cover in the last class? Anyone? Last class কোথায় শেষ করছিলাম?
So optimizers.
স্যার হ্যাঁ অপটিমাইজার পর্যন্ত
আর কিছু পড়েছিলাম অপটিমাইজার ছাড়া?
না স্যার।
ব্যাচ নরমালাইজেশন পড়েনি?
ব্যাচ
জি স্যার, ব্যাচ
নর্মালাইজেশন করা হয়েছে।
নরমালাইজেশন পড়াইছে।
আচ্ছা, আর কল ব্যাকস পড়েছিলাম?
জি স্যার।
আচ্ছা, এগুলো পড়েছে না? আচ্ছা, ঠিক আছে। Okay, so today we'll going to talk about transfer learning. This is actually very important when we apply, especially in CNN problems, any deep learning. For any deep learning related works, transfer learning is very useful. Related applications. So any deep learning related applications. So this transfer learning is very useful. Okay. So when it is useful or how it is useful. Let's try to get some idea of this transfer learning first. First of all, let's think of it like this way. Say, for instance, some of you know how to ride a cycle. Okay. Those who know how to ride a bicycle, will it be easier for them to ride a bike? Or for those who don't know how to ride a cycle as well? কার জন্য সুবিধা হবে? যে অলরেডি বাইসাইকেল চালাতে জানে তার জন্য বাইক চালানো সুবিধা হবে, নাকি যে কিছুই জানে না তার জন্য? Again, think of it like this. So say, for instance, you know how to drive a car. Will it be easier for you to learn how to drive a truck? Or will it be easier for someone who doesn't know anything for him? Which one will be easier? So the idea is something like this. See, if you already know how to ride a car, how to drive a car, it will be easier for you to learn how to drive a truck because you already have some knowledge, you have some skill on how to drive a car. You can use that skill on a different task. Similarly, in this scenario, you already know how to ride a cycle. It will be easier for you to use that skill to how to ride a bike. Okay, so it's like using some skill, some developed skill or knowledge for one task, some developed skill or knowledge for one task, using it on another task. Okay, so whatever skill that you have or knowledge that you have gained for one task, you use that, okay, in another task to get some benefit from it. Okay, the benefit can be in different way. For instance, in the car, when you know how to drive a car, you already know some of the functions of how to drive things, what is the steering wheel, how to control those things. You already know something about it. Then you just have to like allow yourself, practice yourself to learn how to drive a car, how to drive a truck, which is a bit difficult compared to a car. But now, this same concept, we actually utilize this concept in every day. Okay, as a human being, we actually use this concept every day. Whatever we do, we actually use our past experiences, our past knowledge to actually adapt ourselves to new tasks and new scenario. Okay, and this concept is also similarly applicable in deep learning related tasks as well. We can actually use this concept in deep learning as well. Okay, so the idea is to leverage, okay, the knowledge that we have learned that you already learned. Okay, leverage the knowledge that we already know. Acha, how it is possible? For instance, in machine learning, when you actually develop different machine learning frameworks, these were like individual or isolated learning. Okay, for one task, for instance, if you are designing a system to predict, let's say, fault diagnosis, you are predicting some faults or predicting some cancer or house price, things like that. Okay, now these were separate tasks, different tasks, and for each of the tasks, you are creating a separate different models. So for this one, you had model 1. For this one, you had model 2. This one, model 3. Individual, okay, isolated. Each one has a different training process, different models, different training process, and separate. So that was the scenario in machine learning. But in deep learning, we can actually have the benefit of transfer learning. Okay. In machine learning, normal, this kind of task, we have isolated learning, but in deep learning, we can actually take the advantage of transfer learning. Yes, we can take the advantage of transfer learning. Now, why do we need to take the advantage, or how can we do this? Try to understand this question first. Why do we need it? So say, for instance, for one particular task, okay, for one task, let's say X-ray image, okay, X-ray image, let's say chest X-ray image. You want to diagnose pneumonia from chest X-ray images, but you only managed to take around 400 images, only 400. For instance, you only managed to get only 400 images for this particular task. Or say another task, like you want to predict some disease in a potato leaf. Okay, so for this kind of particular task, you have to take images of the leaf of different potato trees. It is very difficult to get. Okay, so finding some images on which there are some diseases, okay, different problems. So this is very difficult task, and you are unable to manage. Let's say you have only 1,000 images, very small. So for different tasks, it is actually very difficult, especially in deep learning, to manage good amount of data. But these deep learning algorithms are usually very data hungry. Data hungry means they actually require a lot of images to properly learn. Okay, you need lots of images. Okay, to have lots of images to get good performance. So what do I mean by good performance? Good performance means actually, you see, if this is your accuracy, okay. You see, when you have this accuracy, if this is your human level performance, means, say, if a human being like a doctor looks at this chest X-ray, out of this 400, he will be able to tell if the person has a pneumonia or not. Okay, he has this expertise. Also, an expert in this kind of task, he will also be able to tell whether the leaf is actually affected by some disease or not. But you yourself will not be able to tell that. But what the expert can do, that is the human level performance. And when you are trying to design a CNN network, when you are designing a CNN model or deep learning model to predict this task, you want to actually get this level. You want to get to this level. Whatever the human level performance is, you want to perform as good as that one. Okay, that is considered as a good performance. So if a human expert can do this, you want to reach that level. That our CNN model, our deep learning model will also be able to achieve that one. Okay, that is our good performance. And to get to this point, to get to this good performance, a deep learning model requires a lot of data. Okay, quite a lot of data. How much? For instance, if you remember the ImageNet dataset, in the ImageNet dataset, there are around 1.5 million images. Okay, the models were trained on 1.5 million images. That's a huge number of images. Okay, it's not 100 or 1000. If I 1000, 10,000, 100,000, then you have 100 or 1 million. So that's a large number. Okay, acquiring and getting this huge amount of data is actually practically very difficult. In different applications, it's not even possible. You can never get this amount of data for this kind of biomedical applications. especially in biomedical applications, this is extremely difficult to get large amount of data. So what does it mean? So that means that when you are developing this kind of deep learning models, especially in biomedical imaging tasks, your model will not be able to perform well. Okay, your model will fail. And that's something we cannot actually take. We have to have some good performance from this model as well, because these are very critical applications. Okay, we want to perform well, but we don't have this amount of image, this amount of data to make the model perform to that level. So solution of this kind of scenario, when you do not have enough images, when you do not have enough data, one thing that we can do that will help us improve the performance is this transfer learning. Okay, when you do not have a good amount of data, your transfer learning will help you improve the prediction performance. It will help you improve the accuracy. Okay, any question? Any question? Okay, so you already know there is another way to get actually improve the performance when you do not have enough images. What is that approach? কেউ বলতে পারবে?
So augmentation.
Yeah, data augmentation is another approach. When you do not have enough data, that you can use data augmentation. But see, there is an issue with data augmentation. Why just not use data augmentation? See, when you are doing data augmentation, you are not adding new information. Okay, new information means you are not adding new images. Rather, you are just changing the orientation of the data. That helps your model reduce the overfitting. Okay, more generalized, but it does not add any new information. Okay, and also in some of the cases like this chest X-ray, will not able to actually perform, you will not be able to perform data augmentation to a large extent. Okay, so for instance, if you rotate the image, chest X-ray image, it doesn't actually add anything. You don't have to rotate the chest X-ray image because you always look from the front view. You don't look in the horizontal view. There is a certain way you actually look at this chest X-ray. Yes, you can do some contrast adjustment, some small modification, but still the modification that you can do in this kind of biomedical images is very limited. So the use of data augmentation is limited. In certain applications, it is very good. Okay, and it is important, but in certain cases, it will not be able to help you. It will not be able to benefit you too much. Okay, in scenarios like this, transfer learning will help you achieve something that it was not previously possible. Okay, so that is one thing. There are other things that we learn, that we'll understand gradually as I actually continue. You'll understand. Acha. Now, if you do not have any questions, let me move towards. We saw why it is important. Now let's see. Let's try to understand this process first. How or what it is. Now, see what the CNN is actually trying to do. What the CNN is actually trying to do. Now, the CNN is actually kind of like a hierarchical representation, right? Hierarchical representation of convolution and other filters, convolution filters and pooling layers, things like that. Okay. So what these layers, what this convolution layer or pooling layers, what they are trying to do is that they are trying to extract some features. They are trying to extract some features or patterns, okay, or shapes from the data. Okay. So this convolution layer, pooling layer, all of these things are trying to extract some patterns from the data. Okay. And they are just not trying, they are actually learning. And this process is actually, they are learning. This convolution filter, all of those things, they are learning to extract features from the data. That will be more accurate way to say this. These convolution layers, they are learning to extract features from the data. Okay, through which, through there are certain weights, through some parameters. Okay, during training a CNN model, we learn the parameter weights, the parameter values that will help us extract certain shapes from images. Okay, that will extract some features from the image, some patterns from the image. So we learn those particular set of weights that will help us extract some patterns from the images. Okay. So during training, let's say if you have, like in the ImageNet, you have the image of a cat, image of dogs, different breeds of dogs, you have image of horses. So the CNN that is trained on the ImageNet, like our VGGNet or our AlexNet, they are trained, when they are trained on the inception, they learn how to actually represent a cat through certain features, how to represent a dog through certain features, how to represent a horse through certain features. And these parameter values that we have, they actually controls these things. These parameter values actually determine whether it is a cat, whether it is a dog, or whether it is a horse, things like that. Okay. So these parameter values hold this information. These parameter values hold this information or this knowledge, okay, to how to extract patterns from those particular images. Okay. So these parameters have this knowledge how to extract certain patterns from those images. Now, think of it like this way. See, if these parameters, let's say this inception model was trained on this kind of animal data set, animal data. So these parameters that were actually we learned when we actually trained this model on the animal data set, they learned how to extract patterns from the images from the animals, how to differentiate a cat from a dog, how to differentiate a dog from a horse, things like that. But now let's say you have a different task like, for instance, you are trying to divide like a flower classification system. Okay, you want to differentiate different flowers like roses. Okay, then you have like কি বলা হয় ফ্লাওয়ারের নামটা সব ভুলে গেছি, sunflower. Okay, now this model, the model that actually knows how to differentiate cat, dog, and horse, will that work to differentiate these roses and sunflower? কাজ করবে?
না।
কাজ করবে না, তাই না? Of course not. It should not work because the parameters that you have here, they are designed to differentiate between these cats and dogs. They are not designed to differentiate between roses and sunflower. So they should not work, obviously. But here is a catch. What is the catch? You see, like I said before, our CNN is a hierarchical representation. What does it mean? It means that our CNN has different layers. Layers like you have first convolution layer, pooling layer. Again, you have this flows through another convolution layer, another pooling layer. This goes through another convolution layer, another pooling layer. Then goes on. Then you have this fully connected layer. You have another fully connected layer. Okay. Then you have this prediction. Okay. The softmax prediction that will actually predict you whether it is a cat or a dog or a horse. Okay. Or an owl or a rat, things like that. Different elements. So see, our CNN is this kind of hierarchical representation step by step. So from the images that we actually feed the network, it starts to learn from the first layer. It learns how to extract some patterns from this. Whatever it does, whatever this first layer does, based on this second layer works, and based on this third layer works, and so on and on. After we are like reduce the image size, learn lots of features, we flatten it and add some neural network architecture, artificial neural network architecture, dense layer to finally make the prediction. Okay, step by step. That's why it is hierarchical. But see, what actually happens inside is that these first layers, the first layers in the CNN, they learn these layers, these weights that you have learned. You have learned some weights here. Let's say weight 1, weight 2, a huge matrix, large matrix, weight 3, like this way. These first weights, these first parameters learns how to extract certain shapes from the object. Whatever the object is, it learns to extract some shapes like edges. Okay, so a normal values, a random values of the filter will not be able to extract edges from an image. Okay, you have to learn it from the process, from training. So they learns what kind of filter values, if I add, what kind of filter values should I add, that will extract edges from those images that you have. Okay. Similarly, you don't have just one filter like this. You have hundreds of filters like this that actually learns to extract some shapes, some edges from the images that you have. Okay. So these are the first layers. So first few layers try to learn this kind of shapes. Okay. Then these shapes in the later layers gets actually combined together. They actually get combined together. Then in the later layers, like before we have the flatten, in the later layers, you have some like characteristics features like eye. Then you have this nose shape, okay, or tail shape. These things are learned in the later layers. So the weights that you have in the later layers, they actually represent these ones. Okay, how to extract an eye shape from an object, how to extract a nose shape. And they actually obtain those things from the previous layers, like this way. And then when you flatten it, this last one, they actually perform the prediction task, just like normal prediction. They actually perform this prediction task, followed by this softmax layer. Are you following? So if you are understanding, so what we can do, you see this information before I go to this level, up to this portion, say for instance, how to extract some shape information from an image, how to extract the age information, whatever we learned here, these weights that we have learned, we can actually utilize those same weights to extract the shape from a flower. করতে পারবো? What is the shape of the flower? What is the shape of the petal? Okay, things like that. Can we use these weights to extract the same shapes like this ways, the edges from those images? করতে পারবো?
জি স্যার
Less confident or full confident যে করা যাবে? Full confident?
মানে ফার্স্ট ফিউ লেয়ার্সে তো স্যার আমাদের প্যাটার্ন রেকগনিশন ডিফারেন্ট হবে, বাট সিস্টেমটাও রেকগনাইজ করা উচিত।
Okay, so the thing is, you should not, the thing is, it's like half মাঝামাঝি. মাঝামাঝি means it will be able to detect some edges and it will be enough for some cases, but in some cases it will not. I will explain why. Before I go there, let's just assume, for now, let's just assume, if, let me write it like this way. If the tasks are similar, then it will work. Then it will work, not just work, it will work perfectly. Similar means, what I mean by similar, let's say you are different breeds, you have one model, different breeds of dog. You have a one classifier system, machine learning model, that is actually trying to differentiate between different breeds of dog. Okay, so whatever the weights that you have learned, okay, the weights represents how to extract features from the dog images. Now you are trying to, and so let's say this is your model one. Now you are trying to do a similar task, like different breeds of cats. And now you see, in these two tasks, they are very similar. Similar means the shapes of the dog, whatever the edges or whatever the patterns that you learn from the dog at the earlier layers, it will be very much similar in case of dogs as well as in case of cats. So when you have this kind of similar task, you will be able to use this knowledge, whatever the ways that you have in the earlier layers, you can actually use this in the first, in model 2, when you try to extract the features from the cats. So because these images, these weights, they actually extract patterns, some edges or shapes from the cat dog images. Whatever they are doing for the dog images, they can do the same task for the cat images as well. Are you following?
স্যার
হ্যাঁ বলো।
এক্স্যাক্টলি সেম ওয়েটস দিয়ে কাজটা হবে?
If the tasks are very similar, they will do. ফর দ্য ফার্স্ট লেয়ার্স এক্সাক্ট ওয়েট দিয়ে কাজটা অনেকখানি হয়ে যাবে। আমি সেটা নিয়ে আরো বলতেছি, আস্তে আস্তে আরো আসবে, বাট just to give you some confidence now, that if the tasks are similar, same weights will do. Okay. So if the tasks are similar, you will see, then you can actually use this, whatever you have in the first weights that you have learned for another task, you can use those weights directly for this task as well. Okay. So what is the benefit? What is the benefit of doing it? Why not actually just use, why not just like retrain it from scratch again?
Time save.
হবে।
Hmm?
Time
Time
save
save. Why not retrain from scratch? One issue is time, of course, computation time. So if these words actually can actually help you, then obviously these words are able to help you extract features, then we can use it. So that will reduce the training time for you have. Okay. Whatever you learn, why to relearn something that you have already learned? Okay. You have edge detection, you have loop detection, these things you have already learned from this kind of patterns. So why not just use it? So that will save a lot of your time. Acha. Now, this is one thing. There are other things that we are going to discuss one by one. So, acha, first of all, let's see. When you are trying to use this, okay, let's keep it up to this one. I will talk about other things a little bit later. So, to understand this, to finish this portion, so whenever we are trying to use this kind of transfer learning, so learning, using the weights of one model and use it in another. So, this kind of transfer learning, we are not doing for all the layers. We are not taking the weights of all the layers. Rather, we are taking the weights from the initial layers, usually the top layers. Okay. So if you have, say for instance, this VGG16, এটা ট্রেন হয়েছে কিসের উপর বলো? কোন ডাটা সেটে? The model was trained on the ImageNet dataset, right? How many categories were there in the ImageNet dataset?
1000.
So 1000 category, right? So this model, this VGG16 models, whatever the weights that you have, 138 million weights, these weights actually are designed or actually learned to extract features, very low level features from a wide variety of data sets. Okay, extract low level features, that edges, these are called low level features, from a wide variety of data set, from a wide variety of data. So we can use these weights that we have, the VGG16 have, in our task. Okay, we can start with that one. See, the VGG16 has total 16 layer. In total 13, I have convolution layer, and the layer 3, I have fully connected layer. Now, we never use this fully connected layer because this is specific to a particular task, because this fully connected layer are designed to predict a particular categories, this 1000 category. So we don't use these last fully connected layers for our for transfer learning. What we use out of this 13 convolution, we can use this all 13, or we can use this top 5, let's say top 5 or top 7 or top 10. Okay, take the top layers, the weights that you have in the top layers, you take all those. Okay, not the later layers. Is it clear? আমার কথা বোঝা যাচ্ছে?
জি স্যার।
So whenever you are using transfer learning from one pre-trained, so this model is already trained, so we call it pre-trained model on another data set. So whenever using transfer learning from the pre-trained model, you omit the fully connected portion and take the convolution weights from the convolution layers. You may take all the weights, you may take some of them. Okay, you may take only top of them, like 5 or 10, whatever you want. There are many ways you can go, and you take that and use it for your own data. Okay, now let's see how to actually, how, okay, এটা গেল হচ্ছে আমার কিভাবে বলছিলাম, what do you do. So what you are trying to do, and let's see how to actually add this transfer learning in our task. কিভাবে করা যায়? So in normal scenario, let's say you are trying to create a BART classifier. Okay, you have these BART images. Okay, you have this convolution pooling flowing through another convolution pooling, flowing through another convolution pooling, going through another convolution pooling, blah blah blah, dot 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 dot, dot, and you have the final prediction. Now the problem of this scenario you have is that you have a very limited number of BART images. Okay, you have trained on a very limited number of BART images. Okay, so let's say you have only 1,000 images that you actually managed to collect, BART images. So when you are actually training this chain and convolution layer, these weights that you actually find here, these weights will not be good enough to extract the patterns from the good patterns from the BART. Okay, because you have only limited number of images, it will not be able to learn properly how to extract features, how to extract patterns from the BART. Is it okay? বোঝা যাচ্ছে আমার কথা? So when you have this kind of limited scenario, limited data scenario, you are unable to train your model properly. Okay, that's the problem. So what we can do, we can use transfer learning in this scenario. So how can you use transfer learning in this scenario? What do you do? Instead of using this one, you see, instead of using this model, at first, all the BART images that you have, you pass it through your pre-trained model, your pre-trained layer weights. Pre-trained models weights. So pre-trained model probably, let's say, instead of BART, so the pre-trained model, let's say it was on other animals, okay, like cats, dogs, and other things. You have a pre-trained model, let's say M1, that was trained on other animals like cats, dogs, horses, things like that. So when you are designing this BART system, you are unable to train it properly. So you put whatever you learned from this one, the top portion, not the bottom portion, the top of this model, and put it there directly. Put the weights there, that value. Then you place your whatever you have. Then you place your convolution layer, another convolution layer. But now you don't use that many convolution layer. You add 1 or 2 convolution layer. Then you have your fully connected, and then you have your final prediction. So what will happen? You see, these BART images will now go through first the weights of that model, of this animal prediction models. So these models, these weights already knows, a very well-trained model, these weights already knows how to extract patterns, how to extract edges from images of animals. But when you use that for your BART images, it will also perform a similar task, and it will provide you a feature map. It will provide you a feature map where the feature, certain edges detected, certain like loop detections or eyes, everything is detected, and it provides you a feature map. So whatever feature map you get, then you actually train your own model. Whatever you have, you train your model on the feature map that you get from this one. And then you train your model. These weights will learn how to extract patterns from this feature map that are actually the BART images. And finally, you have this classifier that will actually learn how to actually distinguish one BART from another. Then you have this final model prediction. So now tell me, which one will work better, the left one or the right one?
Right one.
Yes, the right one will work better. Do you understand? Why it will work better? Are you convinced that this one will work better?
Yes, sir.
So you see,
It might work better, sir.
হ্যাঁ বলো।
Sir, it might work better. I mean, those are pre-trained weights and pre-trained weights of an animal model. So those weights aren't perfect for bird classifiers. So
Yeah,
the
আমি ওটা নিয়ে,
performance.
হ্যাঁ বুঝতে পারছি, তোমার কথা আমি বুঝতে পারছি, আমি ওটা নিয়ে বলবো এখন, ঠিক আছে? আচ্ছা, ফার্স্ট অফ অল ইউ সি দিস ওয়ান অন দ্য লেফট সাইড দ্যাট ইউ হ্যাভ, লেটস সে দিস পারফরমেন্স হচ্ছে, মনে করো হচ্ছে তোমার 60% অ্যাকুরেসি দিচ্ছে। ওকে, and when you use the right one, you see you are using the weights of another model, similar model. You see, it is similar. If the model is similar, it will give you some benefit. It will help you some benefit to extract some weights. Okay, Then based on whatever you actually learn, whatever your bird classifier, bird images, they actually transform into feature map. And from there, you are now training again from this feature map. Okay. You see, this is never a loss. This feature map, adding this feature map, if they are actually similar, provided they are similar, this is never a loss because now you have something better than the raw images. This feature map is actually better than the raw images that you have. Okay. After you have actually passed it through the weights. So there is a very good chance, if the models are actually similar, if the work is very similar, there is a very good chance your performance is definitely going to increase. It's definitely going to increase. Okay, let's say it becomes 65%. So this is never a loss, first of all. This is never a loss. If you have similar models, just adding this way, adding the top layer, top portion of a pre-trained layer before your model, it is never a loss. It will help you improve the performance. Achha. Now, there is more to this one. Okay. So you see, when you are actually using this kind of pre-trained weights, you are not changing the value of the weights. You are just using it just the same as before. Okay. Whatever previously was, you are using just as same as before. This is called freezing the weights. Okay. This is called, this portion you are okay. This is called freezing the weights. You are not learning those weights again. Whatever the weights previously was, you are using those things directly. Okay. You are using those values directly. Okay. So these weights are non-trainable. If you freeze those things, those are non-trainable. You are not going to train it. You are not going to change it. Whatever the model, whatever the weights was from the animal model, you are going to use them exactly the same. Okay. This is one way to use transfer learning, and it will still perform okay. It will still perform better than this left raw classifier that is using all the data, the raw images. Achha. But you can actually make it better. You can actually make it better. So how do you make it better? That process is called fine tuning. Achha. That process is called fine tuning. Achha. What is fine tuning? You see, in the training process, achha, is it clear up to now? এই পর্যন্ত clear সবার?
জি স্যার।
আচ্ছা, now. Okay. So you see, when we have these weights, the CNN weights, deep learning model weights, we learn those things. Learn these weights using back propagation process, right? And you saw the optimizer, how it works, and you saw the learning process is extremely complicated of a CNN. And that is what actually takes that much of time. When you have a real world data set, it takes hours, sometimes days to actually train a model. Even with actually superior GPU, you still take a lot of time to train your model. Achha. Now, see, these weight values, where we are actually starting, why we are starting to learn these weights. At a start, আমি কিভাবে শুরু করি? When you start training, ওয়েটগুলো কিভাবে শুরু করি আমরা? Random
Random.
আচ্ছা। So random initialization, because there is no other ways. So it's like you are starting from, let's say your weight 1 is, you start from 100, random value. Weight 2 value is 5,000. Weight 3 value is minus 200. And during this training, it is going towards, let's say, fixed towards, after you have trained your model perfectly, it has fixed to 100, now become 2,000. This 5,000 becomes 2,200. This minus 200 becomes minus 5,000. Okay. So let's say this is your perfect weight value. So see, from 100 to 2,000, from going from 100 to 2,000, it has to went through, okay, lots of, ups and downs. Then we actually get it fixed after training. After lots of epochs, lots of update, it becomes this, it becomes this. So this training process is a bit very complex. And these weights now, whatever you have, they now actually represent a certain function. Like say, these weights can represent edge detection from the images of an animal. Okay, things like that. Now, see, when you have a task, let's say this is edge detection from let's say cats or dogs, things like that, animals. Now see, when you have a task of BART classifier, in the first layers, you want to perform something similar. You also want to perform case detection, but now you want to do it for BART images. The shape you see, it is actually quite similar. Whatever the cats have, the edge detection actually scheme is very similar. Now, think of it like this way. When you have this BART detection, is it better to start from again random values like minus, random values like minus starts from minus 500. তোমার weight 1 is now minus 1 for 500. Weight 2 হচ্ছে তোমার 5000. Weight 3 হচ্ছে তোমার 1000. Okay. Now for this BART detection, edge detection, let's say the final, the proper values of edge detection for BART images can be like, it can be like 1500, it can be like 3000, and this value is like, minus 4000. Okay, you see these values, okay, these values are quite closer. It should be closer, not exactly same, but it should be closer because this is for your animal detection edges and this is for BART detection edges, edge detection from BART images, almost similar. বোঝা যাচ্ছে আমার কথা? Are you getting me? Are you following me? So now, when you have this model, you see this start model that was you actually trained, you see the weights are actually learned to went from this to this. Now, when you are trying to design a BART classifier, you are trying to perform the same edge detection type. If you start from random, again, you have to go from this to this, this to this, this to this. This is a very complicated task, right? Instead of this one, what if we start from the weights that you have learned from here? We start from 2000, we instead of taking it as 500, we start whatever our animal model, whatever the weight was for the animal model. From 500, instead of using 500, we take 2000. Instead of using 500,000, we take 2000. এটা কত? 2200. And from this one, we take minus 5000. Would it not be much easier for you to go from here to there than from these random points to this value? বোঝা যাচ্ছে আমার কথা? এই ভ্যালুগুলা যেগুলো হচ্ছে তোমার ফার্স্ট মডেলটা রান করছে, দিস এনিমাল ডিটেকশন মডেলটা রান করছে, এইখান থেকে তোমার এই যে অ্যাপ্রোপ্রিয়েট ভ্যালুগুলোতে যাওয়া সহজ হবে নাকি একটা র্যান্ডম ভ্যালু থেকে শুরু করে ওই জায়গায় যাওয়া সোজা হবে তোমার মডেলের জন্য? Which one will be easier?
Animal data, sir.
So it will be easier, right? That's what we are trying to do in transfer learning. We are trying to have the knowledge, use the knowledge that you have from another task and utilize it for our task. Now you can say, okay, I am not going to go to this portion. I am just going to use whatever I have here. I'm going to use this directly. You can do this, and this will also work pretty closely. You see, these values are pretty close. So that will still work better than random values or training it for a long time. But what you can also do, you start from these values, then train your model to update the model for this particular task. বোঝা যাচ্ছে আমার কথা? Again, বলতেছি, রিপিট করতেছি. You start from these values, the weights of the animal model. You start from these values and learn again for these BART images. So what do you do? Previously, we make these weights freeze. We freeze the weights, so non-trainable. Now you just make them trainable. Trainable means this is like you have new model. Your new model is like this. You have these BART images. It flows through a set of weights from animal classifier. Okay, then you put your convolution, a bit of new, and then you have your fully connected. Previously, these weights were non-trainable. You do not change the weights. You make them as before. But now you make them trainable. You start with these weights, whatever the weights that you have, it starts from there and train it for this BART classifier, for these BART images. So the weights will now update and align themselves to get to a particular value that is actually suitable for BART images. বোঝা যাচ্ছে আমার কথা? Adapt the weights for the BART images. Okay, so instead of using random values, it starts from random stage, you are starting from something that is already working for another data, and you start from weights to update the weight a little bit, adjust it for this particular data set now. And these weights, this update will take long time or a small time. এটা করতে সময় বেশি
Small
লাগবে না
time.
কম লাগবে? Yes, this will take a smaller time to actually adapt it to these images. And also the update will be even better because now it is now have to adjust a little bit. It does not have to learn from scratch. Okay, so now this kind of adaptation will make it work much better. And this process is actually called fine tuning. You're fine tuning your model. Okay, you're adding using the weights, some of the weights from another model, and using it, then updating those things, adjusting those things a little bit to apply it for your own data. Okay, and this is how fine tuning works. Okay, so when you do those things, the most important advantage of that model, the most important advantage of the model is time. The time that will require actually train this model will be reduced. Okay, time will be reduced, then your model will start to perform better, performance will be improved because now you have some weights that is actually good weights. If you're using weights from something that is like ImageNet data, you see the ImageNet data, the models that you have, the weights that you have, the VGG16 model has, it is very well trained models. So when you use the weights for your own task, it will be much better. Okay, it will be much better because the weights are actually very nicely trained to perform this kind of edge detection and any kind of small low level feature extraction task. Okay. Acha. So this is another way to use transfer learning. You can use directly freeze the weights, or you can use fine tuning. This is another way. You can also combine those processes. Combine means you freeze some of the weights and you train some of the weights. Okay, so let's say you are using from VGG16, you are taking the top 10 layers and using it, your top 10 layers. So you can say, okay, I'm going to freeze the top 5 layers and I'm going to update the weights of the later 5 layers. Then you have your convolution, your own convolution, and you're fully connected. So this way, the top 5 layers are usually very low level features, and it is actually the same for different data sets. So you don't need to update. You are saying that I don't need to update. So this will actually require less time compared to updating all the files. So now it will work. Okay, it might work better for your data. So is it clear? The concept is the concept clear how transfer learning works? Any question? Any question? No question. Acha, I believe everyone has understood this topic. I hope so. Now, only 34 জন, বাকিটা সবাই কি ঘুমাচ্ছে? এসি একসাথে না, এসি একসাথে হলে তো 30-60 জন থাকার কথা। আচ্ছা, so this transfer learning, I believe you have the idea. You can actually apply the weights. The weights are actually saved. Whatever the weights that you have are saved in TensorFlow. Let's say the VGGNet, ResNet, Inception, the weights are actually saved, and you have those weights in TensorFlow. Okay, you can also train your model on a particular data and save your weight. Okay, you save your weight from one model and use it for another model. You can also do those things. Okay, you already know how to save weights. There is a callback that helps you perform that task. Okay, model checkpoint callback will help you save the weights for your model. You can externally save your models as well, save your weights as well, and you can use that one for another task. Achha. Now, there is one issue, still one issue. The issue is actually, you see, one of the things that you see, I said that if the data sets are similar, if the data sets are not similar, then transfer learning will not work. What does it mean? It means, for instance, say your model is trained on cat images. Now, whatever the weights that you have learned, if you try to use those things for MRI images, তাহলে হবে? কাজ করবে? করবে?
No, sir.
Okay, so you see the data set has to be similar. Okay, similar, then it will work the best. Okay, if the data set is not similar, it may not actually work properly. Sometimes it can even make the scenario worse. For instance, you see this cat image and MRI images are extremely different for extremely different tasks. So you should not use the weights that were learned from cat images and use it for MRI images training task. Okay. Yes, you can say, okay, whatever I have learned from X-ray images, whatever weights I have learned, I can use that weights to pretend to actually fine-tune the particular weights when you're training an MRI images. That will help you. That can help you to some extent, yes. but still it is better to do it for another set of MRI images. That will even better. As much as similar as you can get, it will work the best. Okay. So I hope this concept is clear. This is all about transfer learning. And with this transfer learning, I believe I have, since I have seen optimizer batch numbers, callbacks, and transfer learning, I have covered some of the, any questions up to now? Any questions? Acha. So with transfer learning, I believe you have understood, we have completed the most of the some basic things that you actually need to actually create your CNN architecture. Okay, all the basic things that you need, like drop-off regularization, batch normalization, then how to calculate different number of parameters. Okay, what are the function of optimizers? Okay, how to the functions of callbacks, how to perform data augmentation, how to use transfer learning. All these things are actually very important to actually create a CNN architecture for imaging tasks. So I believe with this one, we are done with this lecture. We are done with this CNN portion. Okay, how to create one. Now, the next topic, that we have is image segmentation, a particular task. So see, so far we have been working on classification, image classification task. I have given an image, you are given an image, you are given an object, you are trying to classify it into category. Say cat versus dog, cat or dog, you are classifying it into category. This is one particular task of computer vision. Okay, in computer vision, there are different things you can do. One of the things is classification. Okay. So there are other things important and necessary in different biomedical applications is called segmentation. I'll try to give you some introduction about segmentation. Then you are given an assignment. Okay, assignment of particular assignment is given for the before mid. Okay, so do this assignment, that will like your self study and to actually properly understand how different segmentation actually works. After that, we'll start working studying about biomedical imaging modalities, different modalities like X-ray imaging, CT scan, okay, MRI imaging. We'll talk about those things after we finish with this one, from the next class. Acha, now last topic, segmentation. Acha, just like classification is actually trying to classify an object classify an object into different categories. Segmentation performs a different. Before we go there, let's talk a little bit about this one. Say in an image, you have let me show you those things. Achha. Now let me share something. Can you see the screen?
Yes, sir.
Achha. Now look at this image. Okay. In this image, if I ask you to classify, if you ask your CNN to classify, what is it going to classify? Is it going to classify as horse or a human being?
Sir,
কি
horse.
করছে?
Sir, horse.
কেন হর্স? এখানে তো দুইজনই আছে।
Sir, horse বেশি জায়গা নিতেছে।
আচ্ছা। So you see,
It depends, না স্যার?
হ্যাঁ বলো।
Wouldn't it depend on কিরকম মডেল ইউজ করতেছে?
It will depend on কি রকম মডেল ইউজ করতেছি। লাইক মনে করো যে তুমি সবকিছু ক্লাসিফাই করতে পারো। ম্যান ভার্সেস হর্স ভার্সেস ক্যাট ভার্সেস ডগ, এভরিথিং। নাও which category will it fall into? It will give you probability of both horse, both human being, right? দুইটারই probability দিবে। It will give you the probability. You remember how the prediction is made? It provides you probability of different categories. So it will give you probability of both this one, both as a horse and a human being, high probability. You see, so far we actually mostly focused on like one object per image. That's we actually talked about. So in a particular image, you have only one category of images, like either a cat or either a dog. We did not consider the scenario when there can be multiple objects in the same image. Bolo? I didn't hear you. Achha. So far, we have talked about. If you have any questions, you can write in the chat. So far, we have talked about one object per image. Okay, we usually consider this one. Okay, that's what our assumption was. Now, in scenarios, it can happen. There are multiple objects in the same image. Okay, it can happen. So there can be a cat, dog, human being, all of three in the same image. So then what should we do? Achha. In that scenario, it is called a multi-level classification model. Okay, so this will be a multi-level, a multi-level classifier. So it will not only predict the presence of one category, but it can happen that there can be multiple categories. So you have to consider a multi-level classifier system where multiple objects is present in the image. That can also happen. So you can take the top 2 or top 3 categories with the highest probabilities from the prediction. That will also be. So that is like the multi-level classifier. Now, but see, when you are using this classification, when you're particularly talking about this classification, you are not talking about the location of the object. Okay, this information is not something you are actually getting out. Okay. Your model is only predicting whether that is the image of a particular object, whether it is a light, okay, whether it's a bird, something like this. But where is this object located in the image? Is it located in the left side corner? Is it located in the right side corner? So where this object is located, this information is not actually sought after previously. But now we want to know, we want to know where this object is particularly located. That's something we also want to know. Okay. We also want to know what is the category as well as the location. So 2 tasks. I want the category plus the location, both of them, not just one. We want both. Okay, we want both. We want the category of the object as well as the location. Then what can we do? Any question? Any question? Acha. So this falls under the category of localization. Object localization. Okay. So localization means you try to locate an object in the image. Okay. Locate an object in the image, then you detect the category. Okay. Now, object localization is a completely is another like your classification. This is one. Then you have this localization is another concept. Then you have this segmentation. That's something I'm going to talk about a little bit later. So localization is another thing that actually comes after classification. So in classification, you just want to classify. In localization, you want to locate the object as well as classify both. You are trying to perform 2 tasks at the same time. Okay. So now this kind of localization, now this has limited application in biomedical imaging scenario. So we are not going to talk much about localization. I'm just going to give you some brief idea what this localization actually means. You'll see when you have an object like this, আচ্ছা, now আমি খুব একটা বেশি আর্ট পারি না, সো ধরে নাও এটাই হচ্ছে মানুষ, আর কি অ্যাড করবো, এর হচ্ছে একটা ঘোড়া, ঠিক আছে? আচ্ছা, so you see there are 2 objects in the image. Now I don't only want to locate the object, I also want to know we want to know its location as well as the type of the object. Okay, so to do this kind of location, what can you do is something like a bounding box. Okay, a bounding box. Achha. What do you do with the bounding box? You see, you take a bounding box in the image and you slide it like a sliding window. You slide it, you put this bounding box here, then whatever inside you try to predict. Okay, এই bounding box এর মধ্যে কিছু আছে কি নাই, so এখানে কিছু নাই, then what do? You slide it to the next step, then see if there is something like this, then slide it to the next step, like this way, sliding window, you slide it through different steps, then you go downwards, then again slide, then again slide. So when it is in this region, it will see a human face and will tell you that in this bounding box there is a human value is present. So you have identified the object of human face, That is one thing. Acha. If you slide through further and keep going it, and in this scenario, you see you have only one portion of the horse or cat or whatever it is, one portion of it. So it will not be able to classify. But when you go downwards, now you have only the legs. Matha nai, only legs আছে, এখন কি করবে? So problem that this kind of problem happens. So what do? You just don't use one shape bounding box. You can use different shapes. In the first run, you use this shape. Okay. In the second run, use a bounding box, shape of bounding box like this big bounding box. Okay. You pass like this big bounding box around the image. So that will give you in one of the bounding box, you will have the whole object, the whole human being in one bounding box. Also, you will have the whole horse in one bounding box like this way. So there are lots of techniques out there. I'm just going to giving you some idea. Okay. So you keep doing it like sliding with this sliding window technique. You just keep sliding your bounding box and try to find locate the object and then detect, just like a normal classifier, you detect whatever is in the object or whatever is in the bounding box. Okay, that's how we actually perform this localization task. Okay, and for this kind of localization, there are different algorithms. This is called object detection. This is called object detection. Object detection task, and there are different algorithms that is actually available for this one. For instance, RCNN. Okay, faster RCNN. Then you have YOLO, very popular. You only look once. You have pyramid networks like FPN. Okay, pyramid network. Then you have like a single shot detector, SSD, things like that. These are different object detection algorithm. Each has a slightly different technique to detect the bounding box and actually classify the object what is inside. So these are actually forms under the localization topic, object localization. You localize the object and try to classify it. Any question?
স্যার
হ্যাঁ বলো।
লোকালাইজেশন কি শুধুমাত্র একটা অবজেক্টের জন্য নাকি এটা মাল্টিপল অবজেক্ট ডিটেক্ট করতে পারবে, লোকালাইজ করতে পারবে? মানে শুধুমাত্র
Multiple
হর্স
object.
আর এখানে মানুষ
Multiple
থাকলে কি শুধুমাত্র একটা আইডেন্টিফাই করতে পারবে নাকি কিছু দুইটা আইডেন্টিফাই করতে
হ্যাঁ,
পারবে?
এটা মাল্টিপল অবজেক্টই করতে পারবে। এটা যতগুলো অবজেক্ট থাকবে সবগুলোই করতে পারবে। দাঁড়াও আমি তোমাকে ইমেজ দেখাচ্ছি। ওয়েট। Any other question? Okay, so see, this is your object detection. See in the image, you can see here, দেখা যাচ্ছে?
ইয়াস স্যার, দেখা যাচ্ছে।
So you see, when you have this object detection, you have this bounding box. In the left side, you can see you have this, for this dog, you have a large bounding box. For this dog, you have a small bounding box. For this one, you have even a smaller bounding box. So there can be different shape bounding box. Each one actually trying to separate out, okay, different objects and also classify. So it can actually classify multiple objects, detect multiple objects. Any object that you're actually willing to detect, it will be able to detect those things. Is it clear?
Yes, sir.
So this kind of application actually comes in different scenario. Like if you're taking an object of a traffic jam, okay, like a traffic in Bangladesh, so your object detection algorithm will actually detect which one is a car, which one is a truck, which one is a bus, which one is a motorcycle. Using object detection, you can actually particularly detect different things. And you use this concept in different tasks like or self-driving cars. In self-driving cars, you have to have this information. So that is the purpose of object detection. Okay, is it okay? Any question?
স্যার
বলো।
যদি স্যার দুইটা অবজেক্ট মানে স্যার একটা একসাথে ইন্টারসেক্ট করে, ইন দ্যাট কেস কি হবে?
ইন্টারসেক্ট করলে ওই যে অর্ধেক দিবে হচ্ছে একটার জন্য, অর্ধেক দিবে আরেকটার জন্য। দাঁড়াও দেখি কোনো ইমেজ করা আছে কিনা আমার কাছে। I think I should have. No. So in scenarios like this, it will actually try to can you see this image? So if the object is overlapping, things like that, so it will try to focus on the main one first. Okay, so it will try to separate out different objects, but it will try to focus on the whatever is taking the most spaces. It will try to object, but it will see you are using different shapes, this bounding box. So each one will try to detect different objects. So it is possible that if it is not overshadowing the other objects, it is possible that all the objects will be identified. Okay, if one object is completely overshadowed by the another, then the one that you have in the front side, that will be identified. Okay.
Yes, sir.
আচ্ছা, Now we have this object detection, classification, localization, object detection, things like this. Now the next topic is actually segmentation. So see what is segmentation. Now there are mainly two different types of segmentation. One kind of segmentation, one image, this one. See, there are basically two different types of segmentation. One is called semantic segmentation, and another is called instance segmentation. The idea of semantic segmentation is segment all the object. Segmentation means segment all the object first. The second thing is, in semantic segmentation, similar object are not differentiated. So all of these are parcels, so they are not differentiated. But in instance segmentation, you differentiate each and every object that you have, you can get. Okay, so let me give you another image like this. You see this one, in semantic segmentation, all the human beings are like marked red. And then the other things, it should be actually like the road and things like this. For instance, here you can see, and this is like, you have the grass, you have the cat, you have the tree and the sky, like this different color, different region. That is the semantic segmentation. But instance segmentation, you are separating out each and every one of them, each and every one of the person. And you see, whatever the area that person is covering, that object is covering, you are marking that area. Okay. So it's like pixel-based identification. You identify not the object, you identify the entire region that object is actually taking. The object is actually locating the region. You take that region as well. You identify that region as well. So you can automatically understand the task is a little bit complicated. It's not a very simple task. So training these models it will take a little bit longer time. Any question? Is the idea clear? Okay. So now come to our segmentation model or segmentation task. So here, when you have segmentation, what we are trying to do, we are trying to identify the pixels of the object. What pixels or pixel values that particular object is actually particular object is actually holding. So you identify those pixels values. So it's like exact location. You are pinpointing exact location. Okay. So in previously, when you have localization, you are using a bounding box. Okay. So when you are using this bounding box, a portion of the bounding box is the human being, not all the regions. But now when you have segmentation, you have the exact shape that this is the shape that human beings are actually following. So you are finding the exact shape of the object that you have. So exact location, you are pinpointing exact location. So it's called a mask. Okay, it is called a pixel-wise mask. Pixel-wise mask. In image segmentation task, you will try to produce a pixel-wise mask of the object. Okay. So this is called a granular level task. Granular level task. Okay. Achha. Now, so you can ask this question, why do we need this segmentation? Okay. Let me give you one or two examples. You will also read some article, you will also find those things. Provide you some articles, also try to read the study from the internet. Achha. Now, so for instance, say you have cancer cell. Okay, you are taking images of cancer cells. Okay. Now, you see whether the severity of cancer, whether the cell actually represents the cancer cell or not, these things actually depends on the shape of the cell. Okay. If the shape is like very unusual shape, large shape, things like that, it means the chances of cancer is larger. So you have to know what is the shape of the cell to identify or actually give this information whether the cell is a cancer cell or not. So in some of the tasks like cat and dog, you don't need the shape information. But now here you see in this kind of detection task, you need to know the exact shape of the object. Okay, so when you have this exact shape of the object, তখন কি object detection কাজ করবে? কাজ করবে? কোথায় গেলাম? অবজেক্ট ডিটেকশন মানে বাউন্ডিং বক্স, ঠিক আছে? অবজেক্ট ডিটেকশন মানে এই যে বাউন্ডিং বক্স ইউজ করা। বাউন্ডিং বক্স তখন কাজ করবে?
Yes, sir.
কাজ করবে। Does not give you the shape information. Okay, so things like this kind of task, you need this shape information, exact shape of the object. Also, says for instance, self-driving car. Okay, in self-driving car, you want to pinpoint the exact location where this person is standing, exact location or which region that particular object is located. You want to know this information. So in scenarios like this, okay, you need this kind of segmentation task. Okay. Also, if you look at satellite images, you see when these satellite images are taken, it's important to identify which portion of the image is a hill, which portion of the image is a house, okay, which portion of the image is a field, which portion is river. So you have to segment different areas of the image, okay, regions of the image. You need to do those things. So in this kind of task, image segmentation is extremely important. Okay, any question? No question? Acha. Now let's move a little bit forward. Acha. Now this kind of segmentation can be classified into two categories. One is called semantic segmentation. Another one is instance segmentation. I already showed you the images, so I believe you already understand what is the difference. Now, to perform this kind of segmentation task, there are different ways. Different ways means previously this kind of segmentation used to fall under the image processing task. Okay, so there are different image processing based techniques to perform segmentation. Later, when you have this convolution neural network convolution techniques established, when they actually established, then CNN is also applied. Different CNN models are developed to perform this kind of segmentation task. Okay, so if I put these things in the category, so one of the different segmentation approaches, one is like pixel value based segmentation. Okay, pixel value based segmentation. So in one of the lab, I have actually already showed you. I'm not sure whether I showed you how to perform this pixel based segmentation. So there are other applications like edge detection. Edge detection based segmentation. You have clustering based segmentation. Okay, then you have clustering. ওটাকে বলা হয় আমি জানি কি বলে এলাম watershed model. তারপর কি কি আছে graph based. Then you have region growing based segmentation, Then you have mask RCNN, UNet, SegNet, things like that. Achha. Let's try to give you some idea, very practical idea. The last three of them, in the previous one I wrote that object detection, we have this RCNN model for object detection. Okay, so when you had something extra for segmentation task, you have to add something extra. Previously, you had a bounding box, then object classifier. Now you have three different tasks: bounding box, object classifier, as well as the mask of the object. So that's called mask RCNN model. Okay, so UNet, SegNet, these things are used in, these are CNN based approach, deep learning based approach to perform this kind of segmentation. Okay, I believe you already have good idea about how CNN works. So this was actually given as an assignment. Try to study an article and try to understand and explain how this one of the model actually works. That will be enough. Now, region growing, this is a particular image processing based, graph based model, watershed, সবগুলোই হচ্ছে image processing based. I will try to explain one or two of them just to give you some idea. আচ্ছা, now let's see. সর্বপ্রথম এটা মার্কস pixel value based segmentation. What does it mean? Now, pixel value, you see, I believe you already have good idea about the digital image. If you don't have good idea about digital image, how they are represented, I have provided an lab manual. I have discussed how digital image works, and also I think a lecture video about this one. So you can actually try to look at those ones for if you do not have good idea about digital images. Now, you see, when you have a digital image, the pixel values represents the intensity of the object. Okay. So the pixel values represents the intensity of the object. So if you have something like this, let's say 2, 3, 4, এটা হচ্ছে 110, 150, 200, 200, 200, 220, 110, 120, 60, 90, 100, 220, 200, 5, 6, 0. Acha, if you have this value, okay, can you tell me what will be the output image look like if you have these pixel values? বলতে পারবা? কে বলতে পারবে? Very simple.
Sir, could you repeat?
যেখানে বেশি সেখানে ইন্টেন্সিটি বেশি।
যেখানে ইন্টেন্সিটি বেশি সেখানে
ভ্যালু গুলো যেখানে বেশি সেখানে ইন্টেন্সিটি বেশি।
yes, intensity
Sir,
বেশি means white, right? 0 means represents the black color, black, and 255 represents the white, because this is a grayscale image, 256 shades. Okay, so in a grayscale image, when you have values close to 0, it will look like black. So this region will look like black, this region will look like black, complete black, this is also black. Here you also have black, the other portions will look like white. Okay, different shades of white. Something is too white, something is less white, like this. So this will be like completely black. Okay, okay, black, yes, এই তো black করতেছি, complete black. Okay, things like this, the image will look like something like this. So this is what actually this digital image actually represents, the pixel value actually represent. So what you can do is something like this. You see, if I say any value greater than, let's say 20, mark it as complete white. Any value less than 20, mark it as complete black. So white means let's make it as 1, black means let's make it as 0. তাহলে এই রিপ্রেজেন্টেশনটা কি হয়ে যাবে? এই ম্যাট্রিক্সের রিপ্রেজেন্টেশনটা it will be like 1 1 0 0 1 1 1 0 1 1 1 1 1 0 0 0, এটা হয়ে যাবে না? হবে? Are you following?
Yes, sir.
So you see now your image, the grayscale image now have binary values, right? So you have converted your grayscale image into two color, black and white. You have converted into a black and white images. So this process is called binarization or thresholding বলা হয়. Thresholding, and this is your threshold, something that we just assume. There are ways, there are methods to actually calculate this one. So in thresholding, what you are actually doing, you are differentiate the values to create a foreground and a background. Divide the image into a foreground and a background. One side foreground means something in the forward, something in the back side, that's the background. Okay, so this is called thresholding. You use a particular value to differentiate the image, to segment the pixel values into two different sides. One is your foreground and another is your background. That will help you detect different scenario. Acha, let me show you, তাহলে আরো বুঝতে সুবিধা হবে. Share this fellow. Okay, can you see the image? দেখা যাচ্ছে? You see, this is an object of a wall, and there is a crack in this portion. Okay, so now, so after reading the image, if I perform this segmentation, you see, now this image is now converted. Now this image is now converted. This image is now converted into white and black. You have this black region that is the foreground, a white region that is the foreground, and black region that's the background, whatever you say. So now you can see your object is now segmented into two different sides, two different ways, black and white. Okay, so this is called a pixel value based segmentation. আমার কথা বোঝা যাচ্ছে? Using this pixel value, you are dividing the image into two different segments. So now they will have black side, black shade, and a white shade. So that is called global thresholding. You are dividing the image into two different shades. You can also do these things for other images, like, so let's say this is the horse image. Now you can see the image is now pixel white. আচ্ছা, আরেকটা দেখাতে চাইছিলাম, এটা ম্যাটল্যাবে খুলতে হবে। আচ্ছা, so I provide you the code. You can actually try to run it on yourself by yourself. Okay. So using this kind of thresholding operation, see, using this kind of thresholding operation, you can do a lot of things. I'm going to mention. Come out, come out. Right. So you see, this was your original image of an X-ray. Okay. And in the X-ray image, it is very difficult for you to differentiate between different regions. Okay. But now you can see when you perform this kind of, there are different thresholding. I'm going to talk about those things a little bit later. When you perform this kind of multi-level thresholding, you can see now you have the different regions. What is the bone? What is the muscle? Everything is separate out. Okay. This is the purpose. This is the purpose of segmentation. You segment different portion of the images. Okay. And one of the way we can do is based on the pixel values. You can see this portion is completely black. This portion is less like not completely black, but almost black. This portion is very bright, and this portion is less than that. So based on the pixel values, the difference in the pixel values, you can segment the image into different regions. That's what we actually perform in this task. Is it okay? So to now. So this kind of thresholding, okay, there are different ways to perform this kind of pixel value based segmentation. One is called global thresholding. Okay, global thresholding. What we just saw in the before. Okay, this one, this black value and white value, this is called global thresholding. It is performed using Otsu's method. Okay, it calculates the threshold that is appropriate and segment the image into black and white, background and foreground. There is also adaptive thresholding or local thresholding বলা হয় এটাকে. So there is also multi-level thresholding that we saw in the last one. Separate the image into different threshold, different regions. So that is one way. Region value based. Now you see this pixel value based segmentation. This will not work for all the images. For some images it will work. But in some images, when the pixel values are more or less similar, you will not be able to differentiate between different objects. Okay, so this works for some images. So this kind of processing task is not fixed. Okay, for one particular set of image, one will work. For another set of images, that method might not work. So it depends. For different scenario, different approach will work. So this is one approach. That is the pixel value-based segmentation. I have provided an article. That article, it is more clearly described. You can actually study those things. The second one was edge value, edge detection based segmentation. Acha. In this kind of task, in edge detection, you see, when you have two objects, the idea is wherever the edge is, that's what is going to separate the two objects. So we have to find the edge of the object to separate these two objects. Okay, so that is called edge detection based segmentation. And to perform this kind of edge detection based segmentation, you have different filter operation. Okay, I believe you already know these different types of filters. So like Sobel filter. Okay, you have Laplacian filter. Then you have Canny filter. Okay, আরো অনেকগুলো আছে. So I think this topic was covered in your digital signal processing class. See, for instance, if you have this type of filter 1 2 1 0 0 0 -1 -2 -1, what kind of edge will this one will detect? What type of edge it will detect? Anyone? সবাই ঘুমাই গেছে নাকি? কি ডিটেক্ট করবে?
স্যার 10টা বাজে ক্ষুধা লাগছে স্যার, ছুটি দেন।
এই যে শেষ প্রায়, আর 5 মিনিটও লাগবে না।
আচ্ছা স্যার।
তোমরা অনেক পিছায় আছো, এই জন্য শেষ করা দরকার। কি ডিটেক্ট করবে? লেফট সাইড এন্ড রাইট সাইড?
Sir, right side.
Horizontal.
This will detect horizontal edges, and this is going to detect vertical edges. Okay, if you perform convolution operation on the image, you see these zero values will make the vertical edge clear. It will clarify the vertical edge, and this one is going to make sure that the horizontal edge is actually detected. So there are this kind of filter that performs the edge detection. And these things, I think, should have been covered in your digital signal processing task and digital signal processing course. This kind of convolution operation and how this works. So you use the same concept here. And another one, the last one that I'm going to talk about is clustering based. Okay, the clustering based segmentation, it has the same idea. You see, previously we used this clustering concept. And if you use the, this is also pixel value, you see, if I perform clustering on this data, if I perform clustering, so these values are close together, right? So the cluster, this will be one cluster, this will be another cluster, and this will be the another cluster, because these values are close together. So when you perform clustering on the pixel values, it will also cluster the different, based on pixel value, it will also cluster different segments into different regions into different segments. And that is what you do in cluster based segmentation. Okay, and this is also very popular. Without needing to train any model, you just actually perform segmentation based on just clustering. So you already know this, how to cluster works. So আমি এটা ডিটেইলসে যাচ্ছি না. So these topics I have provided an article. Read that article properly. Okay, and also how CNN based models actually perform this kind of segmentation task. That will be your self study. Okay, any question? শেষ?
স্যার আমাকে স্যার যে কোনো একটা পড়বো স্যার?
For CNN based, not this one. This one সবগুলোই পড়তে হবে। CNN based যেগুলোর কথা বললাম, like mask or CNN, UNet, SegNet, whichever you actually prefer, that will be your assignment. যে কোনো একটা। Okay, Any question? Okay, please write your student ID in the chat. Okay, we are finished for today.